All right, hello everybody, welcome back to another video, and in this video we're going to be taking a look at an MCQ question from an HL paper 1 from the November 2019 batch. So in this question they've given us a Maxwell Boltzmann energy distribution curve for a given gas at a certain temperature. So first I'm going to really dissect this graph so that you understand what I'm going to be talking about. So what, as any graph, in this you have an x-axis and you have a y-axis. So on the y-axis, you have proportion of molecules. So this is basically all the gas molecules that is there in the container or wherever the gas is stored. And this kinetic energy is, well, what it's quite literally what its name is like. It is the amount of energy the gas molecules have. So when these two things come together, what we really see is that the proportion of molecules. So if supposing we start from 0 and you have 5 kinetic energy, this is just some random unit. I don't know what the units are. I'm just going to put this as 5. And the proportion of molecules at this spot, let's say it's 80. Okay, let's say it's 80%. So if we draw this to this peak point of A, we can say that 80%, or in this case, I'm going to take proportion as in percentage. So 80% of the molecules have a kinetic energy of 5. And if supposing I keep this as 10, and I see that this goes lower, we can see that 10%, only 10% of the molecules have a kinetic energy of 10. And that makes sense because you can't expect all molecules to have an incredibly high amount of kinetic energy, right? There will always be molecules which will have low, there will be molecules which are sort of in the middle, and there will be molecules with a lot of kinetic energy. So this is how a Maxwell Boltzmann energy distribution curve looks like, and this is what it tells you about the proportion of molecules in a gas which have specific kinetic energies. So not every molecule has the same kinetic energy, but you can group them in by percentage. So this proportion of that gas has this much energy, 10% of the gas has 10 kinetic energy, 80% has 5, and so on and so forth, right? So this is just a random example. I've just took very random numbers over here, and I've tried to kind of explain what a Maxwell Boltzmann curve is showing us. So now in this question, they've asked us, how will this curve change if the temperature of the gas is increased while other conditions remain constant? So if we increase the temperature of the gas, that automatically means that the kinetic energy of the molecules will also increase. So for example, this A over here, this 80% that I showed you earlier, this 80% of molecules which have a kinetic energy of 5 will now move on. Because of this increasing in temperature, they might move on to having a kinetic energy of 6. So they might become the majority. And then those molecules which were at 10, at 10% over here, which were at 10, they might move on to 11, and so on and so forth, because you're increasing. That means that more proportion, or a higher proportion of molecules are going to have a higher kinetic energy as a result of the increased temperature of the gas. So, well, how would that affect this curve? How exactly is that going to affect the curve? Well, if we are seeing a trend where the molecules are increasing in kinetic energy and they're moving towards the more extreme side, towards the right, as a result of the increased temperature, this A, for example, at kinetic energy 5, where 80% of the molecules used to have 5, this is not going to be true anymore. This thing is actually going to shrink, because now the number of molecules with a kinetic energy of 5 is going to be lower, because those which were at 5 before the temperature increase are now going to move on to 6, for example, and maybe those which were at 1 will move on to 5. I'm just giving a random example here. So this peak over here is not going to hold true anymore. This peak is quite literally going to shrink. It's gonna squash. It's going to sort of maybe become like this, and we're going to see an increase over here. So the molecules at kinetic energy 10, earlier we can see that over here in the previous graph, it was at 10%. But in the new temperature increase graph, we can see that it's at a higher percentage. That means now more molecules have kinetic energy 10, so maybe 20% have it. So this graph, it has quite literally shrunk, right? It has flattened out, sort of flattened out, and the peak is less steep now. So out of these options, which one is the correct answer? So out of these ones, it says that the option A says the maximum is higher, and to the left of A, which is wrong. That is not the case. B says the maximum is higher, and to the right of A, no, that is not the case. We've discussed that the maximum is not going to be higher; it's going to be lower. So A and B are automatically out. Let's look at C and D. The maximum is lower, and to the right of A. Yeah, that sounds about right. Even though my very rough sketch over here shows the peak being kind of exactly at A, this whole thing is actually kind of going to shift to the right. If you were to draw this a bit more properly, it'll start actually looking like this. It'll start looking like this because of the new peak where majority of the proportion or the majority of the molecules of the gas will have a higher kinetic energy as a result of the increased temperature, right? So this is actually how it will look like, or it'll be a bit more neater. I'm just giving a very rough drawing. So it'll actually be to the right of A rather than the left, because to the left would mean that now a greater proportion of molecules have a lower kinetic energy, which is not true. So it will be to the right. That means C is the correct answer. So I hope you've understood my explanation of the Maxwell Boltzmann curve and how I got to this answer. And this is a very important concept because it comes up a lot in MCQs and even in paper 2 questions. So thank you for watching this video. If you have any questions regarding this concept or any other concept, please let me know on my social media in the comments or send it to me via email and I'll be more than happy to help you. Thank you so much for watching. I'll see you in another video with a new question.